And just like we did with 2 dimensions, then we're going to do with 3 dimensions. So let's kind of review. That is, on 39 through 44, given the following vectors, again, I like to write them this way. You don't have to, of course, but that's me. If I want to find 3v, that will be 3 times 3 negative 5, 2, minus 2 times w. That would be 9 negative 15, 6, minus a negative 4, a 6, and a 4. By the way, you could have distributed the negative n and just added, but whatever makes you happy. So it's going to be 9 plus 4, 13, negative 15 minus 4, negative 15 minus 6, negative 21. You guys get it right. 21, and 6 minus 4 is a 2. And there it is. Just like we did with 2D, we do with 3D, we multiply. Also, if we want to find a unit vector, if you remember a unit vector, u given v, u is take any vector divided by its length. That would be the unit vector. So first I need to find the magnitude of vector v, and that will be the square root of 2 squared plus negative 1 squared plus 1 squared. Magnitude of v, remember I could write a single or double line, it doesn't matter, it's the same. That's 4 plus 1 plus 1, that is just a radical 6. And to find the unit vector u, I will take v divided by its length, and that will be 1 over radical 6, and simply whatever this is. You could, of course, distribute that if you wish. And you could even rationalize the denominator. And this reduces by that 3 times. Any of those will do. Either way, you get the same thing. That's not that big of a deal. And if I want to find the dot product, do you remember that? Find the dot product. Well, the dot product, v dot w, would be what? 1 times 1 plus 3 times negative 1 plus 2 times 1. V dot w would be a 0. And if you recall, the cosine of theta is v dot w divided by magnitude of v, the magnitude of w. Since those are non-zeros and I'm getting a 0 right there, then automatically that's going to equal 0. And if you remember, the angle is still with the same constraints. So if cosine of theta equals 0, that means what? And what is that called? We call it orthogonal. A fancy word for saying perpendicular. And I'm going to conclude this section with this problem. Again, if I take v dot w, that will be 3 times 6, 18, plus 4 times 8, 32, plus 1 times 2, which is 2, and that turns out to be, what is that, 40, 52, right? And when they say find the angle, if you remember what we said, if you could take a vector, multiply it by a number to get the other. So if I take w, which is 6, negative 8, 2, I notice that's 2 times 3, negative 4, 1, which means it's 2 times v. And if I could show that one vector is a multiple of the other, then what? We know that w is parallel to v. Another way of doing that is for you to actually find the angle between them. That will work. Take the dot product, which is 52. Cosine of theta equals v dot w divided by magnitude of v. This is the long way, of course, but that's what the book talks about. They don't talk about them being multiple of each other. Magnitude of v, that is the square root of 9 plus 16 plus 1. Magnitude of w, that's the square root of 36 plus 64 plus 4. That would be 52 over, this is 10 square root of 26 times the square root of, what is that, 104. And that turns out to be 52 over the square root of 2 times 13 times 2 times 2 times 13. If I'm not mistaken, 104 is 2 times 52, I'm sorry. Two times 26. So this turns out to be 52 over, okay, I messed up on this part. Let me do this again. This part. So, square root of 26 is 2 times 13, and 104 is 2 times 52, and 52, if you play cards, that is actually 4 times 13. So this is times 2 times 4 times 13. Well, guess what? 13 clears the radical, and 2 and another 2, and that's 52. So that turns out to be a 1. And I know that if the cosine of theta equal a 1, that means what? Right? And if the angle is 0 or 180, we know that these are parallel. We're going to stop here for this section.